Okay, so quickly we will go ahead with our today's topic, and we are supposed to discuss in our today's topic for the SAP basics, SAP ERP and HANA database basics things. Okay, so as we discuss in our first basic session, also we discuss about the SAP generation shift. SAP started journey with the R2. It's the first generation. It was in 1970, where we do have two different layers of database and presentation layer. And then SAP slowly moved to R3, then R3 to ECC and ECC to S/4HANA. That's what we already discussed. So here, what we will go in little deep. What is there in SAP S/4HANA basically? So we know in R3 we do have three different layers: database layer, application layer, and presentation layer. In ECC also we do have the same kind of layers. Only in ECC there are some plugin interface came up, right? And also SAP did some additions on the OOPS and ABAP concept and these things. But when SAP came up with S/4HANA, here majorly SAP tried to replace the database as a HANA database, right? And as we know, SAP came the first version in 1511, right? So before 1511, from 2010 to 2015, SAP was actually working on the database. So what is that database? And then once we will get a fair idea about the database and these things, we will came to know what are the additional things that now SAP can do, which SAP was not able to do within the ECC. So what are the additional capabilities are there with the SAP S/4HANA? That's part we have already discussed, but I'm just recapping so that we can again go back to the same track and we all will be on the same page. So as I discussed, SAP SAP came up in 2010 as a database, SAP HANA, right? And then BW, then suit on HANA, and then finally SAP S/4HANA. So in our last session, we already discussed what is the sidecar. In 2010 to 2012, let's say, when SAP created the HANA database, okay, so that is nothing, that is not actually, used by the SAP only, okay. Other systems or other ERP system also try to use that HANA database. Already we are having a ECC traditional database, and if we need to replace this ECC whole database with the HANA database, it was a very huge change actually that time. So initially SAP came up with the sidecar solution, where ECC will be running on the same database whatever we do have. And for the reporting purpose, okay, for the reporting purpose, we are supposed to transfer this data from any database to HANA database, and that HANA database, with that HANA database, we used to implement BI, BW for the reporting and dashboard. So basically here you can say with this sidecar scenario or any this thing, you will be able to see there are some challenges with the reporting tool that is called OLAP, okay, online analytical application. So here you can see there are some challenges with our old traditional database that SAP will not be able to do the respective reporting or related reporting so fast, and that's why SAP was looking for some different database to do it. So this HANA database is nothing but our in-memory database, which help us to have a quick reporting or the fast reporting. So the database which were there in SAP ECC was not having that much of capabilities. Now why that is, that we will discuss, because this already we have discussed in our last session. I will quickly jump to the SAP S/4HANA database basics, okay, so that we will go from there ahead. Now, before going there, I just want to discuss like why actually business was looking for some new database which SAP ECC rather than the SAP ECC database was traditional database was already there, right? Let's say many businesses are saying, since they are having already good ERP on place, then why the business actually tried to switch to the HANA database during that period, right? So like the HANA database is too much costly. Still business was looking for that kind of database, right? Because the capability of the current traditional database, what they do have, what kind of different problems were there in their current database. Okay, and here Hana database try to solve that problem. I'm not going to talk all the problems, okay, but from the PP, as a production consultant, PP consultant, I just try to put one business case here, okay, use case here, so that you will understand what kind of additional things that is there in SAP S4 HANA that actually try to resolve the problems which were there in our traditional database. Okay, so let's talk about one of the business case. I'll just try to put it here. I'll try to explain with some diagram so that you will be able to understand. Let's say we do have one customer. Okay, customer is sitting here. Okay, I'll just put quickly customer, and customer is looking for one of the product which we are supposed to manufacture. Let's say customer is looking for one of the mobile phone, and basically customer don't own the mobile phone which is already manufactured with it. He want to configure his own customer while purchasing it. So when we are purchasing any laptop, we are supposed to configure our laptop, like what kind of RAM you need, what kind of data, hard drives you need. So these things you are used to put it, what kind of different colors you can choose it, and you can say, okay, this kind of configurable material I want. So let's say when customer is coming with that kind of configuration, what we used to create a sales order in the system, right? So I will put one by one here, so we used to put a sales order, right? And intentionally I'm saying this sales order is actually customer to order. This is not a make to stock kind of scenario, so I'm just putting it here as a customer to order, right? Then this sales order will be punched to the specific distribution channel from where we are supposed to distribute or give it this product back to the customer. Then it will go to the warehouse from where actually it has to be shipped, right? Warehouse. Now let's say the customer who is requesting for that kind of laptop or that kind of product is sitting in the US. Okay, but my actual manufacturing is happening, let's say, in China or any other country. So when customer is punching a sales order, the requirement has to go to the China first, right? I mean, in the China DC and China warehouse. So what I'll do, I will try to put the same kind of things here, so it has to go to China DC, right? Then China warehouse, and then let's say if to manufacture this, we do have one manufacturing plant sitting here in China. Okay, I'll put production plant A. Also, let's say we do have one more production plant B, which is actually manufacturing same finished material. Okay, which is giving back to the second plant where actually the production will happen. And then it will go to the warehouse, then warehouse to distribution center, and then it will go back here. So if you see here, logistically how it actually works, it will work in that fashion. First, semi-finished material will be manufactured and it will send it to the production plant A, right? Then from production plant A, our product will be manufactured and it will go to the warehouse. Then warehouse, we will be shipping this material back to our distribution center. And this is the distribution center from where we are actually shipping to the US. Okay, it will be through air or something, and then from that warehouse it will go to the local distributor actually, who is supposed to give this product based on the order, right? So with respect to that sales order, he will go back and supply it to the customer. So logistically this is supposed to happen, right? Now if we are talking about, if customer who is sitting here is requesting that product need to be there in 1 week. Okay, he's expecting, I want this product. Hey guys, could you please go on a mute if you are not speaking? Okay. So this is how our logistic flow will happen, like from production B from China. So what I'll do, I'm saying this is my USA, right? And this is my China. Okay. So From China, manufacturing is happening and it is supposed to deliver back it to the customer who is sitting in US. And the request from the customer that product should be ready within a 1 week. Now, logistically, if we are asking that question, is that possible? And they are saying, okay, it's highly possible because yes, we can manufacture this product in a 1 week, in a 1 day only, right? As per the customer requirement. And we will be able to deliver through the air to the US and US to the DC, local DC and DC customer within a 1 week. It is very highly possible. It's very much possible. Now come back to the ERP side or come back to the IT ecosystem, what they are saying. Okay, is it possible in IT ecosystem? Now let's say we are working on our traditional SAP ECC. Okay, in the traditional SAP ECC, what we used to do, first we used to create the sales order for the requirement in the system, right? Then this sales order will transfer the requirement to the distribution center, correct? And to transfer this requirement, we used to have here, I'll put it as a MRP run. We used to run the MRP, okay, so that it transfer the requirement back to DC. Then this DC will transfer the requirement back to the warehouse, correct? Then this warehouse will create the stock transfer request or intercompany stock transfer request for the company which is sitting in China, right? Then in China again, this DC will transfer the requirement to the warehouse back. Then this warehouse will transfer the requirement to the first production plant. And then this production plant will transfer the requirement to the final semi-finished material production plant. So as we discuss here, we do have a MRP run, right, sitting in between, which is actually helping us to transfer the requirement from one plant to other plant or one DC to warehouse, right? So let's say in our current SAP ECC, we used to run our MRP at a night time normally because of our database problem, because of our traditional database, which is not that much capable that we are able to run my MRP at every 1 hour or every, twice in a day. Why? Because of the database issues, it creates a huge load on the system and it may slow down the performance of the system. So let's say in USA, we are running my MRP at night 11 p.m. Okay, and it takes around 3 hours to complete the MRP. Hence, the requirements will be get transferred. The output will come around output will come around 2 a.m. right? So at 2 a.m. around, it will transfer the requirement from sales order to the warehouse, right? So what I will do here, just a minute. Okay, so around one system, we are getting the requirement from the sales order. Around it takes around 3 hours to run the MRP, and then it is going to the downline. Let's say we are running MRP here, okay, and to transfer the requirement to the warehouse, it takes around 3 hours of time. Now, if you are taking an example, if the customer who is sitting here has been placed the requirement at around 6 a.m. in the morning. At around 6 a.m., customer has placed the requirement. We have created the sales order at 6 a.m., but the requirement transferred to DC or warehouse is going around 2 a.m. because we are running our material MRP run in the night time only, right? Because of the database issue. The same time, if we do have scope of planning implemented, everything, we can run the MRP at the same time within the China plant, and we can, able to transfer the requirement on the same time to my production plant. But let's say we do have different regions, right? If we do have a different regions, so altogether my systems are totally different here, okay? So this system, China system and the US system, okay, are totally two different regions. This is USA region and this is China region. So when we are running MRP here in USA, the same time if I'm trying to run the MRP in China, it may be the working time for me here, and it may slow down the system it may slow down the system here, right, in China. So what we used to do, we used to create two separate MRP, one MRP at USA separately, and we used to run the separate MRP in the China for the right. So sometimes we used to have a that kind of interface, and we used to use middleware, right, for that to link both the system, right. Let's take an example. We are having a middleware where we are actually joining USA region, right, to my China region. So whatever requirement coming from USA, it will get transferred with the middleware or something with this system to system, and we are supposed to run my MRP again here in the China night time. So let's say here in China, instead of running the same day MRP, we are running the MRP on the second day. So already we have lost almost 6 a.m. to 2 a.m. of time after customers sending the requirement to the to actually transfer the requirement to the next level because of the system performance issue. And again, here also we are again losing the same time to get the requirement generated. So ultimately what we are doing, we are supposed to deliver this material in a 1 week, and we are losing our time because of my system performance or because of my system capability constraint. We are actually losing 2 days of time to just transfer the requirement, right? So for that, actually SAP was looking, is there any alternative solutions for that? So ultimately what is happening here, ultimately here the lead time is increasing, right? Because of the system performance issue, or we are not able to run our MRP on a daily time, or maybe whenever required, right? Also, it's not still realistic. Okay, why I'm saying it's not still realistic? Let's say 6 a.m. customer has punched one of the requirement. We have run the MRP at 11 p.m. Again at 12 p.m. someone has coming and again creating some more sales order here. Now only one sales order which we have already created, that is already considered in the 11 p.m. MRP. But after 11 p.m. MRP, whatever we are punching the sales order in the system, that will get considered in the net requirement calculation and MRP requirement calculation on a next day 12 p.m. or 11 p.m. right? So ultimately we are not getting the realistic results with this MRP. And that is why actually SAP was looking any kind of alternative solution where we can have a MRP run parallelly with two systems or parallelly with two different regions, or we can run the MRP on a daily basis or maybe hourly basis. But that is really not possible, because to run any MRP, if you are already working on any with any implementation, you must know, like it took sometimes 2 to 4 hours to complete one MRP for one region, right? And when we are transferring it to the second region, it will again take us huge time. Also, we are running the MRP in the night time only because of the system performance issue. When we are running the MRP, due to the database constraint, it creates a huge load on the database, and it slow down the system. So in the daytime, when a user are actually working on the system, we will not be able to run the MRP. So these kind of constraints were there, and that is the reason actually SAP thought to move and change the database itself, so that it will increase the performance, system performance. And that is nothing but my SAP S4 HANA database. Now we will talk about the SAP S4 HANA database, so that you will come to know whatever we discuss. This is one of the typical example I just taken, where MRP run is creating the huge load on the database, and hence we are having the database constraint or system performance constraint. So there are so many other things also during the reporting. Also, you must know, earlier we used to have a BI, and as we discussed, we used to create the sidecar on the same database. When we are trying to fetch the data in any reporting, it's taking a huge time, and for that we used to create the background jobs to get the data from one database to other database, that is in memory database, and from there we used to create the reporting. And again, if you are saying this is not the realistic one, because it's used to transfer the data every 1 hour, so within whatever happening within that 1 hour, that will not be captured in your reporting. So that kind of constraint were there because of our traditional database. Now what we will do, we will try to discuss a detail about the database, so that you will come to know what is the additional things that SAP did with the SAP S/4HANA database. Now we know there is a SAP S/4HANA traditional database, right? In the traditional database, what is there? We do have three different kind of layers. One is presentation layer, second one is application layer, and third one is database layer, right? So what I'll do, I'll try to put here, let's say this is my presentation layer, okay? Then below we do have an application layer, and finally we have a database layer. I'll put little bit big, oh sorry, database layer. So normally this presentation layer is nothing but my GUI screen, from where actually user used to, punch or query the data, or he used to run the script or play the transaction, whatever he is looking for, right? And then this script or transaction code will get interacted with your application layer, where actually your ABAP code is sitting. ABAP code, so it's called as a ABAP dispatcher, right? Dispatcher or your logics, business logics I'm talking about, right? Logics are sitting, right? Which actually used to read the data what user is looking for, right? And then that will come to your final database layer. So here all your algorithms and calculations are sitting with your ABAP application layer, and that will get interacted with your. So I'll put one arrow here to here. Second one is from here to here. This is nothing but my database. Now within the database, what happened? We do have this application layer will be interacted with database to different kind of API. But within the database itself, so we do have a different file system. So what I will do here for a minute, okay, file systems available. So this is nothing but input output file system, okay, which actually get the inputs from the application layer and try to get the data which is stored in your database. So in the traditional database, we do have one disk and drum device. It's a mechanical device sitting, okay? Basically on that disk and drum device, we used to put the data in the form of tables. So whenever there is a command coming from the application layer with file in and out, file system, input output system, it try to query the data with this disk and drum, right? And this disk and drum try to rotate in the backend and trying to get back the data, whatever required, whatever requested by that file system, input output file system, and finally it try to give back to the application layer. Okay. So when it is coming back to the application layer, we are already keeping all our business logics and everything in the application layer only because to reduce the load on your database, right? So your database is always so busy to get the data from the database and get back to the application layer. It's always busy. So what technically what we did, like we tried to in our earlier SAP ECC R2, when there was no application layer, we used to have all your business logics and ABAP coding, everything sitting in the database. And that's the reason your R2 system was very slow earlier, right? So then SAP launched one additional layer as an application layer, which is sitting in between database and your application layer, presentation layer, which is actually working on which is actually looking for the all calculations, summations, aggregations, or all the business logics, and that's has been written. So ultimately, the load on your database is now less. But still, there is one disk and drum device which is actually trying to pull the data from the system, give it back to the ABAP, application layer, and based on the logic which is written in the code, it goes back and give it back to the presentation layer to the user. That's how our traditional database actually works. Now, if you are talking about here, about this part is called mechanical disk and drum device. That is nothing but this. Since this word itself is saying it's a mechanical disk and drum, okay, that means this device actually slow down the performance as of now, because it's take a huge time to get the data from the database and transfer it back to the file system, and from file system to the ABAP dispatcher. Okay, so the main problem with this database, why our traditional database is having so much problems, the performance issue, is because of this mechanical disk and drum. This disk and drum device, when trying to extract the data from the system, okay, it speed it create a very poor speed and performance. I'll put it here like this. Okay, and basically it slow down the system, increase the load. Okay, so this is the major bottleneck with with our traditional SAP ECC database. Now to overcome this, SAP had very long R&D on that, and tried to see what we can do more better to increase the system performance. And for that time, it came up, SAP actually came up with the in-memory database solution. It's not only an in-memory database that SAP has created. Okay, earlier there were SAP. Earlier also there were a database, in-memory database available in the system. Many companies are working on that. So SAP thought to use the in-memory database so that the system performance will get increased. So what is that in-memory database basically? That we will see here. Still, we are not jumping into the HANA database. Okay, here I'm just trying to explain you what is the in-memory database first. Okay, so what happened in the in-memory database, the data. Okay, just a minute, guys. I'll put here. Okay, in memory DB. So SAP think to go ahead with in-memory database to reduce the performance or to increase the performance of our own database. So in-memory database, what happened? The data is stored in the form of charge. Okay. So what I will do, just a minute. Just a minute, guys. So you must heard about the in-memory database that is already available in the market, like, okay. So the basically data which is there in the in-memory database is normally saved in the form of charge. Okay. I will put it here like this. That's fine. Okay. So we are talking about the in-memory database first. So date charge. So the data in the in-memory, this kind of database has been stored in the form of charge. Okay. So the retrieving of the data, whenever we are querying the data with this database, is very fast as compared to the mechanical disk and drum. The mechanical due to the problem with the mechanical disk and drum in this kind of database is the mechanical disk and drum, which take a huge time to extract the data from the database and give it back to your uh, application layer. But here in memory database is actually the data has been stored in the form of charge. Hence, the data extraction from the system is very fast as compared to the traditional database. Now, this was the right solution for the SAP that time to go ahead with in-memory database. So here, as we discussed, the data is stored in the form of charge, in the form of say capacitors and transistors. Okay. so that it's very easy for to extracting the data from the system. But the problem again here is, if the power get failure, okay, here in the in-memory database, if for the time being, if power has been get fail, the all the data which is for saved in the form of charge, it will get lost. That was the issue, that we cannot directly go ahead with the in-memory database and use the same kind of database here in the uh, SAP. Okay, so that's what the problem, that's what the challenge with in-memory database that SAP found, like our data is not safe. Okay, so SAP that time, I mean, when SAP SAP trying to create the HANA database appliance, it was actually planning, or it was actually decided to work with your mechanical traditional database as well as in-memory database. Both should get to work together. Then only it's possible. My data will be safe, as well as my all the calculations, or all the performance also will get increase. So both things should be there in one type of database, and that the both kind of database is nothing but my SAP S/4HANA database. Now, what SAP did in the SAP S/4HANA database, how SAP actually tried to combine both the functionalities together, that I will put it here, so that, okay. So basically what happened, SAP came up with the database where the in-memory database is the right solution to increase the performance. That is in the form of charge. Okay, so that's was the fine. Additionally, SAP kept this rotating disk and drum there to secure the data. Now, how it works actually, so what I will do here, I will try to put these things so that, okay. Now here, when user is coming with any command from the GUI, from the presentation layer to the database application layer, it goes to in-memory first. Okay. Now, in the in-memory, data has been get saved. Okay, and from there only it has been get extracted whenever user is asking for any command back. So all the calculations and these things are now happening with my in-memory. But now the problem again came, if my data is sitting here in the in-memory, that may get lost if my power get fail. So SAP put one additional thing, that is nothing but SSD. That is nothing but save point. SAP created a save point. Okay, I'll put it here, save point. Okay, so I'll put it here. And also there is one more thing. Okay, I'll just put it here so that it will be more understanding. One more thing, that is SSD. We will talk on that. SSD. This is SSD is nothing but just a flash drive. Okay, solid state drive, and this is the save point within the database. So what happened when data is coming from the when the user is creating any write command, okay, when it is coming to the database, first it will go to the in memory. At the same time, it will go and create the save point. Okay, so after every 10 minutes, or after every 9 minutes, this save point will get generated, and this save point will transfer the data to your traditional database. Now what happened, whenever we are creating the data, or whenever we are creating any data, user is creating any write command to the database, it's first going to the database in memory database layer, from where actually any read command is coming. Is very fast due to the in-memory database, it goes back to the application layer and it increase the performance. But now the problem is within the in-memory database also, if we are having a huge data, it will also create a problem, because here in the database, in the in-memory database, the problem is my data is not safe. To get secure the data, what SAP created here in this database, SAP created one save point. After every 10 minutes, this save point will get activated, and whatever data sitting here in the in-memory, that will get saved here in your traditional database, that is your disk and drum. Now the problem again came, if within the 10 minutes if power get fail, my in-memory database, whatever data is sitting here, that will that may get lost, right? So for that, what SAP has created one additional things, that is flash drive, okay, SSD, where when there is a write command coming, it will not only go to the save point, it will go to my this hard disk also. Now, if the power will get fail in between 10 minutes before save point activate, we can easily retry, or we can easily extract the data from this SSD, right? And after the every 10 minutes, when save point is getting activated, my data is getting back and is saving back to my disk and drum, that is my traditional database. Now is already saved. So normally we call it as, within SAP, within this database, there are two kinds of basically layer are. So this layer is nothing but my persistent layer. Okay, this layer is my persistent layer, and this is in-memory database layer. So my Hana database appliance is the combination of in-memory database layer, that is where my this thing data will be saved in the charge, as well as my persistent layer. Persistent layer is nothing but my traditional database. So this is the combination of both, which will be able to give me the on-the-fly calculation with the help of this database, as well as it secure the data with help of this persistent layer. This is the beauty of the Hana database that is SAP came up. So if you try to see here, so whenever that kind of whenever there will be the data failure and data loses chances are there, it call as a your failover strategy also. So somewhere you can able to get that kind of information also, like somewhere it is mentioned like failover or something. So this is nothing but my database, which is sitting in my database, should have in-memory database capability, so that it can give the immediate reaction back to the application layer, and it will give the very high performance. But whenever there is any failure happen, it will also try to save the data in my persistent layer. So this is nothing but my Hana database. These are very high level basics. Okay, I'm also not a technical consultant, but as a PP, as a production planning or as a functional consultant, at least we should know what is the additional things that is there in Hana database as compared to my traditional database. Okay, so guys, I'll take a quick pause here if you have any kind of questions, okay, before moving to the next topic. This is more technical, guys. So I just try to explain how the SAP S/4HANA database works. Okay. Now, what I'll do, I will go to the one of the next topic, that is within the HANA database. Okay, what are the different kind of layers? So normally these kind of questions will be asked in the certification. Okay, for the save point, normally the question ask. Okay, so what is the time duration for the same point? So normally it's around 9 to 10 minutes. So the answer will be like in the minutes or maybe in the seconds or something. So this kind of question for the PP certification or any functional certification, this kind of question may ask. Okay. So I will go and we will discuss a little bit more about the temperature layers. Now we discuss about the HANA database. Okay. We know there is a database where we do have an in-memory database. Okay, I'll say here we do have an in-memory database layer, as well as on top, as well as we have a persistent database layer here. Correct? That's what we persistence layer. Okay. Now this persistent layer is nothing but my traditional database where we do have that kind of disk and drum device sitting, right? I'll put it here like this. Okay. This is my persistent layer. Now, within this database, we normally call this in-memory database layer as a hot layer, where all the, I'll put it here as a hot layer. This layer, we call it as a hot layer. And the persistent layer, we call, sorry, for the persistent layer, we call it as a cold layer. So basically all the calculations, whenever user is, requesting any kind of data, or whether user is putting any write command, it goes first to the in-memory database layer where all the data has been saved in the charges, in the form of charges. All the calculations and everything will happen here in the in-memory database layer, and it gives back the information to the application server, application layer from here only. Okay. Now the thing here is, we know like all the data that is stored here in the form of charges and in the form of tables, right? So what I will do, I will try to put here a couple of tables, okay, so that it will be more easy to understand. So these kind of tables are there, you know very well. Just a minute, I will put here it and then try to. Okay. Okay. So these kind of tables are there in the form table we use to save the data. Okay. So what I will do, I'll try to mute. It's not happening. It should have worked now. Okay. Now, within this in-memory database, we do have a different tables available, okay, where our data has been saved. So whenever there is a write command coming from the user, it first goes to the in-memory database. So if we do have, again, the massive data sitting here in the in-memory database, again, it will create a huge problems to, do the calculations. And again, it may slow down the performance. So within this layer, we always need to have a free space available to do the calculations, to improve the performance. Okay. So the data which is sitting here in the in-memory database, if it get increased, our the basis consultant or the database consultant, what they used to do, they used to pull down the data which is sitting there to the persistent layer here. so that there will be always a extra space available, will remain available within the in-memory database, and it will help us to improve the performance, improve the reporting, improve the extracting of the data. So there are some cases like within the database layer, they can put the layer in that fashion also, in the table in that fashion also, like 50% data will may store in the persistent layer, and 50% data will may store in the hot layer. So basically what happen if you are talking about different kind of material documents, right? So in the material documents, let's say we are working in 2020, so the data, the documents which are generated in last, let's say 6 months, that will always sit here in the hot layer, so that whenever the query is coming or whenever reporting things are coming, we can easily extract the data from there and give it back to the application layer, layer. Or the data which is very old, that can be put it here in the down persistent layer. Or maybe the basis consultant or database consultant can create the background jobs, and they can create the background job in the fashion, in that fashion, on the date specific, the old data which is actually very old, let's say more than a 6 month old data, that automatically get transferred to the persistent layer, so that there will be always extra space will remain available in the in-memory database or in the hot layer, and it will improve the performance. Also, and they can create the background job in that fashion, like if the data in the specific table has not been queried or has not been touched by any user since last 6 days or 10 days, automatically it will go and sit down to the persistent layer. So the the data which is not actually required for everyday reporting purpose, or the table which is not actually getting hit on every day, that kind of data we basis consult can pull it down to the persistent layer, so that our in-memory database, in-memory layer will always have a free space, and it will improve the performance. Now the question come here is, if user is having a read command for the data which is sitting here in the persistent layer, then what will happen? The data which is sitting here, for that actually user is actually asking for the report for that. Then what happen? The database has an inherent capability that will automatically transfer this data whenever that kind of command is coming, automatically transfer the data back to the in-memory layer, and from here it will get reported back to the user. So this is the beauty of SAP S/4HANA database. Okay, that help to increase the performance of the system like anything. Hence, our data is always safe here in the persistent layer in the form of mechanical disk and drum device. But whenever there is a query coming from the user, that data will not be directly read from the traditional database. It will always get read from the in-memory database, which is in the form of charges, and it will give the quick response back to the user. Okay, and to make a security, make the data secured, what we are doing, SAP has created the save point within the database, and has also launched put solid state drive, which actually when data is coming, it actually gets saved in the solid state drive for the time being, and after save point is getting activated, it will get saved in the persistent layer, and that data which is there in the SSD, that will get get archive whenever it goes, the data has been saved to the save point. With the save point, it has been saved to the database. Now you can see here within the database layer, the hot layer will help us to do the calculations, and cold layer will help us to secure the data. And the database has an inherent capability. Whenever there is a read command for the data which is sitting at the cold layer, it will automatically transfer this table back to the in-memory database, and it will do the calculation and give back to this thing to the user. So guys, again, I'll take a quick pause to understand if you have any kind of doubts or questions on the different kind of layers. So this is also one of the certification question, okay, normally asked in the PP, MMSD, any kind of functional certification, like what kind of, how the data has been saved within the S/4HANA database in the form of colors in the form of, let's say, layers or in the form of something else. Okay, so the right answer is the data has been saved in the form of layers, temperature layers.
So Pankaj, I do have a question.
Yes.
Pankaj, like in the earlier slide, you told like whenever data is coming, there will be a save point activated, and
Hmm.
after 9 to 10 minutes, the data will go from in memory to persistent layer.
Yes.
And in the next slide, when we are talking about like you are saying like 6 months of data will be sitting in memory database where reporting will be easy. So how it works? So when the data will be coming in memory database after 9 minutes, how what will take place? So
Yes.
whether entire data will come to persistent layer or like because save point is
Yeah.
nothing but you are moving entire data from in memory to persistent layer.
Hmm. Hmm. Yeah.
But
True.
in the next slide, when we say like 6 months of data is already sitting in memory database, what does that mean then?
No, no. So normally what happen, that's what the thing is. So my disk and drum, that mechanical device, is actually sitting in the persistent layer. Okay. So what happen whenever the data is coming, whenever read command, the write command is coming, here what we are saying, after save point, we are transferring and keeping my data safe here in the disk and drum. But in the in-memory database, why? So it's not automatic, or it's not a, hard user, or the you can call it as a basis consultant. What he used to do, he used to, within the layer, he used to transfer the data manually from in-memory database to the persistent database whenever he feels like there is a load on the database. So when user is putting the right command, when user is creating one transaction, let's say one migo, okay, and he's trying to put the post one data entry. So what happened, that data will first come here in your in memory database, okay, and after 10 minutes it will go and save it to your persistent layer disk and drum device. So now your data is available here as well as here. Okay. So whenever read command is coming from in-memory database, he will go and fetch the data and get it back. Now the table what we are talking about here is the table. Now let's say this is the table of Mad Dog or MSEC table. Okay. Now this table, whole table, is available in both the system. Okay. The data which is coming here in MSEC table, when I'm creating the Migo transaction, first it will come and sit it in the in-memory database, so that if someone is asking back, I can give it back to the user. But this table, when we are talking, this table has already saved in the disk and drum device with the save point. That means the same table is available here as well as here, right? Because data is already saved in the table. So data is available in disk and drum as well as in memory, means the date wise, let's say for first 6 month data, this table what we are talking about here is saved like this. Okay, just a minute, I'll put it here. This table is saved like this. Okay, with the save point, this last layer is there in the database, persistent layer, and the top layer is still in my in-memory database. Now let's say in the in-memory database there is a huge data coming, and I don't have any space available to do the calculation. That time what this guy, basis consultant, will do, basis consultant will try to push down the table data here. It doesn't mean table is not available here. Table is still available here, but only the last entries which are there, last 6 month entries, he will try to pull down it to the again back to the persistent layer, so that here data is available. Here extra space will be available. So indirectly, the meaning of that is the table will always be available in both the layer, the same table. Okay, it's not a two different table. My MSEC table, or now is a Mad Doc. Okay, Mad Doc table is always available in my in memory as well as in the persistent, but the data inside that table will always go down whenever that basis consultant will try to pull down. Whenever basis consultant will see like the space is not available in the in memory, he will try to pull down the data
Got it, Pankaj. It's
right?
clear.
And
Really,
whenever
thank
the
you so much.
query is coming, it will, due to the data inherent capability, it will try to pull up the data in the in memory and try to give it. So the basic fundamental is whenever there is write or read command coming in the database, it will always work with in-memory database and not with your traditional database or your disk and RAM persistent layer. Okay.
Got it. Got it. Thank you.
Yeah. Okay.
Yeah,
Yeah.
Pankaj, one clarification, Pankaj.
Yeah.
So I've read somewhere while preparing for certifications, there is
Hmm.
a warm layer also. Is it true or
Oh, sorry.
cold?
It's yeah, yeah. It's my mistake actually. I'm sorry. Thanks. So this is actually the warm layer. Okay. So my persistent layer is called as a warm layer. Okay. And okay, I'll just correct the things. Hey, thanks. So whenever there is a data in memory, that is hot layer. Persistent layer is nothing but my warm layer. And additionally, there is one more layer that is out of my HANA database. Okay. That is out of my HANA database,
Okay,
and that is called as a cold layer. And this is nothing but your archiving layer. So if you want to archive the data which is sitting here, so it can be any database, okay, any DB. So if you want to archive the data from your HANA database, you can, because since your HANA database is too costly, right?
yeah,
So
yeah.
if you want to, archive the data, it will go down to any database, and this any database is nothing but my cold layer. Yeah,
Okay,
yeah, I'm sorry for that. Okay, thanks.
yeah,
Yeah, that's how it's actually work. Okay.
okay,
Yeah.
okay. Thanks, Pankaj. Yeah,
Okay, so I tried to actually explain these things at a very high level since, as I said, I'm also not a technical consultant, but as a PP consultant or any functional consultant, at least we should know there is some inherent capability or in these things in the HANA database that actually helps to increase the system performance, and that the system performance has been increased in that fashion. Earlier, it used to take a 3 hours to run any MRP, right? 3 hours to run the MRP. Nowadays, with SAP S for HANA, it comes to 3 to 10 minutes. So now thing is, wherever you are looking for, that's why when I was discussing about this use case, we were talking about the data still after MRP run also is not a realistic result, because at 6 o'clock someone has given the sales order. We are running the MRP as 11 o'clock in the night, and still it's taking 3 hours of time. Okay, so now after every hour or after every half an hour also you can run the MRP, or on the event base, whenever there are sales orders are coming, you can run your MRP and get the correct results. So the data transfer or requirement transfer is now fast, and that's what the expectation from any business or the business scenario or any kind of company, like that's how it should work. Again, as we discussed, like when we are running our MRP in the night time, and this is the case what we discussed earlier, when we are punching the sales order at 6 o'clock and we are running MRP, let's say 6:30, that's fine for me. And again 31 or let's say 6:32, we are punching 10 different sales order. But again, my next MRP run will happen in next 1 hour, let's say. Still my data is not realistic, correct? Because that 30 minutes is still a delay. But now due to the my database inherent capability, we can run MRP at any point in time. So whenever we feel like, okay, there are a huge sales orders coming inside and we need to run the MRP, we should not wait for next 30 minutes to run automatic job, right? You can simply go and run your MRP that time also, because my system now the system performance is good, right? So this is actually the S4 HANA database, capabilities that actually helps to increase the system performance, and ultimately it, help the business in various functionalities like MRP and other things. Now, what we will do here We will jump to the next topic, that is our data footprint reduction. Okay, and before going ahead, like let's say we know, like earlier there was a ECC database, is a traditional database. Now there is a SAP S4 HANA database, is in-memory database, and this has a very good performance, and performance has been increased like anything. We can do on the fly calculations anytime, we can run the MRP. But how SAP did it possible? How SAP actually work and try to increase the performance by using this SAP S4 HANA, and how SAP actually did this possible, that we will discuss it here. So the first thing is SAP tried to first reduce the data footprints. That means if you are talking about any kind of database, if you are taking an example of your cell phone itself, okay, you might found like the same number or the same person number you have been maybe saved twice or thrice. So there is a huge redundant data redundant available in the system. In our ECC, in our ECC also, we do have a different tables to save the same kind of data. Okay, so what I will do, I to give very high level, so that first we will understand what is the data footprint. Okay, and then we will go ahead and we will see it later. Discuss the other things. Now in our current database also, if you look into the system, we do have different kind of tables, correct, to save the data. Let's take an example of table MARD. What is MARD actually doing here? Anyone? What is the table for MARD? Anyone can unmute and tell me.
Storage location wise material data. Material at storage location level.
Mm-hmm. Material as storage location level, correct. The stock basically. Okay. So here in the MARD table, we used to save the stock of the material, right? Is that correct? Or is there any other?
Yeah, all storage
location wise stock
and the unrestricted stock.
Correct. Stock. Good. Now let's take an example. We do have MB51, right? What MB51 talks about?
The moments.
Correct. Material documents. In that material document, we'll say, okay, for X material, 101 moment, 100 quantity. Then X material, 261 moment, 50 quantity. Correct? This is my MSEC table. Agree? Now, if I do have a MSEC table available, here I do have information available saying, okay, on this day, 100 quantity has GRN and then 261 issued to the production order. Now available should be 50, correct? So the current stock situation should be 50. Then why we need this MARD table back? We cannot, we simply, we no need to have this MARD table. We can go and query MSEC table and do the calculation and get the information back, correct? So whenever I'm saying what is the current stock of X material, why system SAP has created an extra table of MARD, and here it is saying, okay, 50 stock is available. So whenever I'm saying MB52 report, okay, it is going to MARD table, pulling the information and saying, okay, X material, 50 stock available. But I'm saying, okay, as information, the single source of truth, that is my MSEC table. I can directly go here and query the data and get back to the user. So I no need to have this kind of data. I really don't require this MARD table in the system, but still it is there. Why? Because if we are talking about now, let's say we have done the implementation, let's say 3 years back, we do have n number of material documents for this material, right? And after down the line 10 years, there will be the huge list. When I'm saying MB52 for X material, we are going, system is trying to query the table that is MSEG, and try to do the calculation, it will get, the all calculation will go on a toss because of the database. It will create a huge load on the database, correct? And that is why SAP has created that kind of different tables where SAP try to put the stock information. So whenever MB50 is coming, it is going to MR and getting back to the user. So normally, if you are saying this is a typical example of redundant data, correct? Same information we are saving in the system twice. So that is actually not required, right? So this is why SAP first think how we can reduce the data footprints. It will help to increase the performance of the system. Now that I just give you one example, okay, to first make you understand how the data footprint. Okay, now we will talk in detail about the data footprint reduction. How SAP did the data footprint reduction. Now we will talk. Okay. Okay, I just remove these things. Okay, good. So we know why data footprint reduction is required, because our in-memory database is too costly. Let's say, okay, if I'm putting all the data on the in-memory database, and it will take a huge database to save my data, right? So it's too costly. So it's necessary to reduce the data footprint. Correct? Simplify the data structure. As the same way what we discussed earlier, if I'm having the same information available in two different tables, and when we are creating any kind of codings or any kind of logics, we always get confused, like at what table we need to put it, right? And ultimately my data structure is now is little more complicated. Okay, if I'm saving the redundant data in different kind of tables, right? Also, I want to increase the performance of the system. For that also, it's necessary to increase the to reduce the footprint. As we discussed, if I'm having one mobile, let's take an example of 16 GB memory. Okay, and the RAM of that mobile is just 4 GB. My RAM itself is a 16 GB. So it will create a very good performance, correct? The same way here, what we are talking about, to increase the performance, if I'll reduce the data footprint, if my data earlier is, let's say, 600 GB, somehow I will be able to reduce it to the 5 GB. Same data I'm talking about, okay? Same data. Then definitely my query with the 4 GB or 16 GB, whatever I do have, it will ultimately increase my performance, right? So that is the necessity that we need the data footprint reduction. Remove the redundant data. That's what we discussed earlier. Why we need a MARD table? It's not required. To remove that kind of table, we need to do the data footprint reduction. Now this is the thing, data keep increasing. That's what we discussed earlier also. Down the line, 6 years after implementation, we do have a huge data entry in the system, and that ultimately create a huge load on the database, right? So our data in the system is continuously increasing, right? Every day we are creating so much transaction in the system, and hence my data is increasing continuously. So ultimately it's creating a huge load on the system. So to keep, since my volume of the data is increasing, I need to work how I can reduce my footprint, how I can reduce my data from 1600 to 5 GB by different ways. And definitely it will help us to give me the good calculation, fast calculation, right? So my data structure, current ECC data structure is too complex, okay? Because of that kind of different tables and these things, or current data structure is too complex, it create a huge problem. Like let's say, when I'm creating one report, same like MB52, okay? And instead, for the ABAPer, instead of giving a logic with MARD table, I do have give the logic for MSEG. Go and do the calculation over there. First 1 year, let's say it's a ZMB52, okay, with some additional information. The first year it will, give the very correct results and it's a good result. But after 10 years, when it is trying to again querying the MSET table, what will happen? It will create the load and it will slow down the performance, right? So the data structure, what is current ECC system is too much complex, and that need to be, that need to be simplified. That's what SAP thought with the SAP S/4HANA. Ultimately, you slow down the performance. Coding is complicated. Redundant data can improve the read data. That's what we discussed now. So these are the different reasons. Okay, these are the different reasons. Actually, SAP was looking to do the data footprint reduction. Now I'll go to the next slide where you will come to know what SAP capabilities are there within the data footprint. This is what my traditional database is. Okay, 593 GB. We discussed initially in 2010 when SAP HANA came in 2010, right? So I was talking about here. Yeah. So in 2010, when SAP came up with first product as a HANA, it tried to reduce the data footprint from 600 GB to 118, that is 120 GB. It's around 5 times data reduction, guys. There are different ways to do it. Okay, then we will go and we will try to discuss how SAP actually tried to do it. But you can imagine here 5 times data reduction without removing any table, because when first time HANA came, and it is a S4 HANA. There is a difference in HANA and S4 HANA that we already discussed. I'll just quickly tell you. HANA is just a database. Okay, when SAP came in 2010, that time SAP didn't deleted any table from the system. If you do remember, in suit on HANA, there were this transaction available, MB 1A, MB 1B, this kind of transaction available. Now in SAP S4 HANA, there is only one transaction, that is MIGO. On the HANA database, when we used to use a suit on HANA or BW on HANA, that time, although my database was going to HANA, but these transaction codes were available, MB1B and MB1A, right? Now these transactions are not available. So what I'm talking about, when it was first time it came to HANA in 2010, that time only, without removing any table, okay, without deleting any table, without removing any data, SAP was able to reduce the data footprint from 593 GB to 118. That means 600 to 200. That is 5 times reduction. Now the same example, you can take it. My mobile is having memory of 16 GB, okay, and RAM of 4 GB. It was having a very good performance. Now my data has been reduced to 4 GB. Ultimately, my performance should be very high as compared to the earlier one. This is happened with HANA. Then when SAP came up with the SAP S4 HANA as a product in 2015, first version, 15.11. Okay, here what we are talking about, 10. So this is the right example. Okay, in 2010, SAP created the database. That time only 5 times reduction happened. But when SAP came up with the separate product S4 HANA on HANA database itself in 2015 as a 15.11, that time, I'm going back here. Yeah, that time it has been again reduced to 42 GB. Now you can see 600 to 42 GB directly. Now you can again take the same example. Now earlier it was the 16 GB in 4 GB. Now it's only 2 GB, even not 2 GB also, right? Now you can imagine your system performance. And then I'm talking about one more additional column, that is actual. Actual data is just 4 GB. 8 GB. What is this actual? This is the actual. The layers, what we discussed earlier here. My data is already available, but I try to push the data in the warm layer. And only, in the hot layer, what I try to put the, normally used data. Now, 600 GB database has been reduced to 8 to 9 GB. Now you can imagine what is the performance of my SAP S4HANA system. Earlier, my MRP run was taking, let's say, 5 to 6 hours. Now it should be 10 to 15 minutes. If my MRP run, I could complete one plant MRP run within a 10 to 15 minutes. I no need to wait for night time to run the MRP. I can run my MRP in a daytime. Okay, even I can run my MRP hourly basis also, or whenever I required also. Now the same question. Earlier, my results of the MRP was not realistic because at night time at 12 o'clock, what is the stock situation? What is the sales order, or what is the incoming PIR situation? Based on this, SAP has created the net requirement calculation and given you the purchase requisitions, right? But the output which has SAP has already given to you, it may not be that much correct. But now with this kind of data footprint reduction, if my performance has been increased from 6 hours to 10 minutes, I can run my MRP in a daytime. It will not slow down the system performance, and I'll get the realistic results. That is called on the fly calculation. We used to call always on the fly calculation. Whenever data we are querying the data, we are getting the quick response from the system. And when I'm saying my MRP, so that's why in SAP S/4HANA, earlier we used to call it as a MRP run. Now it is MRP live. It's not a real word. Okay, MRP live means we can run our MRP at any point in time and we can get the realistic result at any point in time. But it doesn't mean it's a real MRP live. Whenever you are punching the sales order, immediately system will not go and automatically run the MRP. Still, we need to schedule the job, or we need to manually trigger the MRP. But with the help of this data footprint reduction, okay, with the help of this data footprint reduction, this is now possible in SAP S/4HANA to increase the system performance from 5 to 6 hours for MRP especially I'm talking about to 10 to 15 minutes. Okay, now what we will do, guys, we will one by one try to discuss how SAP actually did this data footprint reduction. And basically, as a functional consultant, I many times I heard like we are always confused about the column wise data structure, row wise data structure, and everyone wants to want to understand what is that actually and how it actually help us, or how it actually help in the data footprint reduction. That we will go one by one and we will try to discuss. Okay, any questions? I'll take a quick pause here. If you have any question, you can ask.
When you say that actual, are you talking about the in-memory database, only that part, the hot layer only you're seeing?
Yes. Sorry, can you come back?
When you said that actual is 8.4 GB, is it just that hot
Yes.
layer you're talking about? Okay.
Yes. That's what here actually you can see it here. The actual data and historic data. So what I'm saying, normally what we used to do, we used to put the historic data in the warm layer. So actual data will be remain there in your in-memory database. So you are always you are talking to only what we discuss here in that session. I mean this slide. I'll just go back. User is always talking to only in-memory database layer. Although you do have a data available in the persistent layer, that is historic data, still whenever user is querying the data, what is the report for 2011, let's say. Now that data, the data is available in your persistent layer, right? But we saw there is an inherent capability of the S/4HANA database. Whenever we are calling the data which is there in the persistent layer, it automatically immediately picks up the table and put it in your in-memory database, right? Just a minute. Yes, old data. And now I'm the user and I'm querying the data. I'm pulling the report from 2010 to 2015. Now that data is not there in in-memory. Okay, that data is in the persistent layer. So immediately that capability is there. Immediately that table data will get moved up to the in-memory and try to give it back. Again, it will come back and sit it in your persistent layer. And that's what I'm here it's explaining.
I understand.
Yeah, your actual data is now only 8 GB because all data now there is in the disk and drum device, and that is for your data save point. Your calculation is only happening with this data in and this is also in the form of charge. Even that is not nothing, right? So it will ultimately give you a very good performance. And that's why now in SAP S/4HANA, you might seen like there are so many Fiori applications are coming, analytical applications are coming. Okay, we will see even when we will go in detail about our discussion, some different kind of analytical application. Within that application, you will get a huge information. Like in current MB52 report, you will get only stock information and which stock and which batch and these things. But if we do query the we be able to log in to the Fiori and try to get some analytical information, system will not only provide you the stock information, system will provide you the current open PR, open POs, what you need to do next, what are the PR which are not getting delayed, this kind of information, everything with different colors. This kind of information is available, and this is possible only because of now we are reacting only with 8.4 GB data. Okay. Oh, sorry. Okay. So what we will do, we will first talk about traditional database to HANA database. Okay. How SAP did the data footprint reduction. This is so when we are talking about the traditional database. Okay. So this is nothing but without removing any data, without removing redundant data. I'll make very clear. SAP able to reduce the data footprint reduction 5 times, 600 to 180. And there are different ways to do it. It's not so what are the different ways to do it? One is data compression. Second is column store. Then any attribute as an index. So 1, 2, and 3. With help of these three functionalities, SAP within the HANA 600 to 120 GB, 5 times data reduction happen. I'm sorry. So removing index, then column and data structure, column wise data structure, inverted index, and data compression. These are the 4 different things that SAP did here to. Okay. Now we will discuss one by one. Okay. First we will go and discuss about the removing index. Anyone has any idea about the indexing? What is index? Anyone?
To
Seems like
fasten the data.
Correct.
it just work as a reference value.
Yes, reference value. Fast.
We are
Fast.
basically we are basically storing a combination of key
Yes,
fields to make the data
correct.
fetch
This is more
fast.
technical. Correct. We are creating the index to get retrieve the data from the table with the help of index. It's very easy. I'll try to explain in a very layman language. Let's say, just take an example of one book. Okay, and it's, let's say, 1000 pages. Now within this 1000 pages, we do have an index on top of that, right? It may be 2 to 3 page index. Correct. Here, what we used to do in the index, we used to create topics and the page number, so that whenever you want to search anything, you can simply go to the index table, right? And simply you can see, okay, this information should be available on this page. Correct. So this is the help of index. Like you can easily retrieve or you can easily extract the data from the thousands pages book with the help of this index. But normally when I'm saying, okay, I do have 3 pages of index available, that means it has been already increased the footprint. So now whole book is 1003 pages. So in normal, if I do have a different information available and I want to get the very quick and right information, I need to increase the index. Instead of 3 pages, I may need to increase to 10 pages, correct? or maybe 100 pages. If I'm having 100 pages index, then it's very easy. Within the index pages, I'll get all the information, and I can directly jump to the specific topic and get the information, right? If I'm having 100 pages index, then it's nothing. So whole index is my, the book, and I can get the information from there only. So with the help of this index, we will be able to get the information here from this book. So this is the main usage of the index. Now let's say, as I discussed, let's say this book is of one of the SAP PP certification exam book, okay, SAP PP exam book. And now here I'm coming into the book and I want to know what is repetitive manufacturing. What we will do, we will first go to the index and we will see, okay, on which page REM has been mentioned. And we will try, let's say on 100 page, REM information is available. Then what we will do, we will directly jump into the book and we'll go and try to open the REM on 100 page and try to get the information. This is very easy for me. But now in SAP, what happened, or any kind of things, it's not like that. Like you will go and just check the 100 page and you will get the data. Still, you will go ahead and try to search whole 1000 pages to get the right information if index is not there. Let's say I don't have this index page here, as we discussed, and I'm trying to get the information of REM. What we will do, we will go 1 number, 2 number, 3 number, 4 number, like that way. We will reach to the 100 number page. We will get the information and we'll come back and we'll say, okay, now we do have REM information available. But still it will not stop since index is not there. Still it will go and try to read all the 1000 pages and try to see whether REM information is still available somewhere. But if index is there, we can get the information very quickly for that. So this is nothing but the index at a very layman language. Now, when we are talking about the data footprint reduction, the first thing what we say here is removing index. I am supposed to remove the index which is sitting for 3 pages. And I would just want to, reduce the data footprint. So the earlier book is 1010 pages because 10 pages index was there. What will happen? I will remove the 10 pages. Ultimately, it will reduce your data footprint. But how you will search the data in the system? That is the main challenge then. To do this, SAP came up with, I'll again go back here. SAP came with inverted index functionality. Okay, so first thing, somehow we will be able to remove the index with the SAP S for Hana database, and we introduced inverted index. Now, how that inverted index is coming with the column and data structure, that is the thing that we need to discuss in detail. And then you will come to know, okay, these things are interlinked with each other. By removing the index, somehow we are able to, do the data reduction. And with the help of that data and column wise structure, we actually able to reduce the data from 600 to 120. Now, if I'm saying I'm just removing the index, and the same example what we are taking here for 1000 pages book, only 3 to pay or 10 pages of index is there. So if I'm removing only 10 pages, how much data reduction will happen? Nothing, right? So if at in our table also, in MSEC table, we do have a indexing and everything. If I'm removing just the indexing, it will not create that much impact, okay, or like 600 to 120 GB. There are something else inside. So when we are saying this MSEC table indexing and this part, when ABAP is creating some Z logic, he also try to put some different kind of index on the top of that table. These are the standard index available for MSEC. When ABAP is writing some coding, he also try to create his own index. He also try to put some more index. So ultimately, my data footprint from this specific table get increased from 100 to 120. Now, what first thing SAP did? SAP tried to remove this indexing. So ultimately, 120 has been reduced to now 100 only. Now, still there is a very big gap from 600 to 120. This is 5 times. This is still very big gap. Now for that, what SAP did? SAP work on the column and data structure and inverted index. And this is the main important things that we will discuss now. So guys, we are already 9. So what I will do, we will discuss this topic because this is a very, huge topic, and it will take a huge time to explain. Okay, it will take more than 30 minutes or more than that to explain you the column data structure and inverted index. That topic we will discuss in our next incoming session, and then we will go ahead. Okay. But before that, I will just stop here for the today's discussion. I just want to know if you have any kind of questions on the data footprint reduction and what we discuss about the basics of the SAP S/4HANA database. Anything? This is more a technical, okay? As a PP consultant or as a functional consultant, we no need to go in more detail, but at least how data compression is happening, how column structure will help us to reduce the data footprint, how removing indexes is very easy. Okay, easily you can see, okay, from 100 now we have removed 10 pages, now it is 90 pages, so it's somehow reduced the footprint. But the actual footprint reduction will happen with the column data structure and inverted index, and also the compression of data. Compression of data is a very typical example. Like, let's say we do have this kind of figure that 1 1 1 3 2 6, that kind of figure is supposed to save. So instead of saving this as a 113 like that way, we have a different way to save it, like 1 3 3 2 6, that kind of. So I'm not sure, it's more technical, but that's how we can try to reduce. I mean, SAP try to reduce in the data footprints. Like one has been putting one time or something, or maybe like this. If it is 0001, so it will be put like this 0001 326, like that way. I'm not sure. This is more technical, but that's how. This is also a very small thing, data compression. Okay, that maybe I'll discuss in next session, but we will discuss in next section about the column and data structure and inverted index in very detail, so that you will understand how SAP jump and try to achieve the data footprint reduction from 600 to directly 118, I mean 120 GB. Okay guys, any questions before closing out today's session?
No, from my side, Pankaj. Thanks for the session.
Okay, thank you.
One doubt, like out of this topic, like what are the certification books we have to go through?
We do have, see, which certification you are looking for. You are looking for, let's say, SAP production planning and manufacturing. Yeah. So we do have already one book available for that. Okay. And in that, actually in PP certification also, we used to get some questions on the data footprints and these things. And that's the reason I'm putting this topic at a very high level, so that you will understand. But when you refer that book, that we will share it later point in time to you. That will be more than enough. Yeah.
So you are having a particular book. I got the materials, but I was confused. Like there were
there's so much material available. Okay, but it's better you can refer only one book and try to run all the different kind of production planning related scenarios, because this is my personal experience. Like, it's not only it will come only from the book. There will be some kind of questions, logical questions also. Like, if this planning strategy is there, and if stock is this much and this demand is this much, what will be the plan order quantity? That kind of question also come. So you need to run your end-to-end scenarios for that, or you need to understand the basic functionalities of the different planning strategies. Yeah, we will share you that book, no worries. So okay, thank you very much guys for joining today's session.